Jai Hind to all of you. I am Priyanka Sharma, Assistant Professor, ECE Department in Ajay Kumar Garg Engineering College. I am going to present my video lecture on Fundamentals of Electronics Engineering subject, that is BEC 101. So in this subject, we are going to discuss about the topic which is related to Unit 1. So we are going to start with the topic, that is we are going to discuss about the rectifiers, that is the most important application of diode. So diode, we already know what is diode. First of all, diode is a device. Diode is a two-terminal device, two-terminal electronic device which can allows current to flow in one direction. So by using this advantage, we can use this as a rectifier. So diode is a two-terminal device. It is made from p-n junction and it is a semiconducting material. So one is p side and another is n side. So in this we can see the working of diode. Diode works in two bias. One is forward bias and other is reverse bias. Since we know that this has a cut-in voltage. Let's say if it is a silicon diode, it has a cut-in voltage of 0.7 volt. So if we make it forward bias, then it will allow the current to flow after the cut-in voltage, that is 0.7 volt approx. So the current starts flowing in this manner. For forward bias, if we see the graph, it starts flowing the current rapidly after the cut-in voltage. Now if we see the reverse bias condition, there is no current flow. No current flow will be there. No current flow. So we can show it in the graph like this. This shows a very small current which is due to minority charge carriers. So by this we can say that in forward bias, ideally diode can behave like a short path. It behaves as a short path. So we can say this circuit is get closed. Now for reverse bias, no current is flowing. That means it can behave like a open path. So open circuit can be represented by this. So by using this characteristics of the diode, we can use it as a rectifier. So let us now discuss about what is rectifier. Rectifier is a device which is made from diode and which converts the AC signal into DC signal. So this AC to DC signal conversion requirement is which is the case of inverter. So in this case we can convert the AC signal to DC signal. So diode can pass the AC signal and convert it to DC value. So we can say the definition of the rectifier. Rectifier is a device which converts the AC signal into pulsating DC. Actually rectifier is a part of DC voltage regulator, DC voltage power supply. So for power supply we have to connect one rectifier first. The input is AC signal. This AC signal is in the input of rectifier, and after this we get the signal which is either half wave rectified or it is full wave rectified. So this half wave or full wave rectified signal is said to as pulsating DC. So to convert this into purely DC signal, we have to first connect the filter. We can connect the RC filter circuits here, RC filter, and after this we can connect the regulator circuit. So after this we get the pure DC. This is the pure DC output. So in this way we have to focus on the rectifier part. that how the rectifier works. So rectifier is basically of two types. Rectifier is of two types on the basis of signal generation, that is half wave rectifier, and other is full wave rectifier. Full wave rectifier is again of two types. It is classified as center taped rectifier, center taped full wave rectifier, and other is bridge rectifier. So let us see about the different type of rectifiers one by one. First of all, we start with the half wave rectifier. So half wave rectifier is a circuit in which it uses one cycle to flow the current, other cycle is not used. So in this, one cycle will is operating and other cycle is not operating. So when we see the circuit of the half wave rectifier, it consists of only single diode. This consists of only single diode and a load is connected here. Now the input is given to the diode from the AC power supply or AC mains. So we have to connect one step down transformer here, because diode has a tendency of using only the smaller voltage. So for AC main signals can be first stepped down to a lower voltage, then it is transferred to the diode. So this diode can be taken as ideal diode, or in ideal condition, in forward bias diode is treated as short path, and in reverse bias it is treated as open path. Now if we see the working of the diode, and we will take the output here, we have the input Vi, which is given here, this is V in. So we will get the output corresponding to this. So we can do the analysis of this half wave rectifier. So this analysis of half wave rectifier can be done by using different cycle. First we will start with the positive cycle. For positive cycle diode is, or we can say this end will become, for positive cycle this end will become positive and this end will become negative. So this positive will make the diode forward bias and it is treated as short path. So the current is flowing, which is also AC in nature. So the output will be, what is the output? Output will be V out equals to V in. So we will get the same output which is given to the input, the positive half cycle. So this is the output of positive half cycle. So this is the output. Let's say if its peak voltage is Vm. So here also the peak voltage obtained is Vm in case of ideal diode. Now if we consider the negative cycle, for negative cycle again we can say the diode, this end will become negative, and now this will become, the circuit will be reverse bias. So in reverse bias condition, it is treated as open circuit. So open circuit will be look like this. That means in this open circuit condition, we can see here no current is flowing. So if no current is flowing, so there will be the output that is equivalent to 0. So for the negative cycle, we are not getting any output. So for positive cycle we are getting output, for negative cycle there is no output. So we can say only the positive cycle comes into the output side. So this is the working of half wave rectifier, and if we see finally the output of the half wave rectifier, it will be look like this. This is the input and this is the output. For positive cycle we get the output, for negative cycle the output will be 0. So this is the half wave rectified output. Now we can also calculate different parameters of the half wave rectifier. So different parameters of half wave rectifier which is related to this, we can see here. First parameters of half wave rectifier. First we can see the average DC voltage, which is represented by VDC, average DC current, which is represented by IDC. Third is RMS voltage, which is represented by VRMS, RMS current, which is represented by IRMS, and fifth is efficiency of rectifier, and this is represented by eta. Sixth is we can have the peak inverse voltage, peak inverse voltage. So this is said to be PIV. So these parameters we can calculate for different type of rectifier also. So let us see this is this one by one. We can see here. So on the basis of the graph obtained or the output obtained, we can calculate the average DC voltage. So first, the average DC voltage VDC can be calculated by the formula. We have the graph, output graph is like this. This is the output graph and its peak voltage is Vm, and now if we take the total time period is T, then this time period is T by 2, and if we take this 2 pi, then this will be the pi. Now if we apply the for calculating the DC voltage, we have to take the integration of this output. So we can have the integration of 0 to T V out d dt divided by total time period. So this is 0 to 2 pi now, and this V out T is equals to Vn for positive cycle, and we know what is Vin for AC signal, Vm sin omega t, and we can also integrate with respect to omega t. So now if we substitute here the value Vm sin omega t, Vm sin omega t, or we can first substitute Vn sin omega t d omega t divided by 2 pi. Also we can see here we get the only for 0 to 2 pi, 0 to pi signal, and pi to 2 pi it is 0. So we can bifurcate the integration 0 to pi, it is obtained Vm sin omega t dt d omega t, plus pi to 2 pi it is obtained as 0. So we have the total time period which is equals to 2 pi. Now if we integrate this and apply the values or substitute the limits, we get VDC for half wave rectifier is Vm by pi. Similarly, if we want to obtain the second parameter IDC, we have IDC given by VDC divided by R. So VDC can be written as Vm by pi into R. So Vm by R can be substituted as Im by pi. So these are the two parameters we can derive here. Now next we are going to see the third parameter, that is the RMS voltage. RMS voltage, that is VRMS. It is also given by the formula, that is root mean square. So that means we have to take the integration from 0 to 2 pi again. Here we have to take V out square d omega t divided by t. So we have to take square of the input, then we have to take the mean, then after that we have to take the under root of this whole value. So now if we substitute these values again in the same way, 0 to pi, we have Vm square sin square omega t divided by t, plus this is 0, and now we will take the square root of this. We will again obtain the value of RMS voltage as Vm by 2. So this is the VRMS obtained in case of half wave rectifier. Similarly, the fourth parameter, that is the IRMS, can be again given as VRMS divided by R. So this VRMS is Vm by 2 R. So this can be written as Im. This is Im by 2. After this, we can have the fifth parameter is efficiency. Efficiency can be calculated as eta. It is the total DC output power obtained divided by input AC power. So if we talk about the power, then we have to take the output values. So we have P out divided by P in, and this is given as V out or VDC square divided by R, VDC square divided by R divided by VRMS square divided by R. So this can be cancelled. So we can calculate the efficiency as VDC square divided by VRMS square. So VDC square can be calculated as VDC, we already know, we already calculated Vm by pi whole square divided by what is VRMS? We obtained Vm by 2 का whole square. So we can have the value 4 by pi square, and this is obtained as around 40.8%. So this is almost half, less than half percentage efficiency we obtain for half wave rectifier. So that's why we can analyze from this all parameters. Half wave rectifier is generally not used. We can go for the full wave rectifier. Now next is PIV. The last parameter we can calculate is peak inverse voltage. That is the voltage which is obtained in the reverse direction. Peak inverse voltage. Peak voltage that is obtained in the reverse direction. So this peak inverse voltage for half wave rectifier can be calculated in the reverse bias condition. So in reverse bias condition, diode is open circuit and we have this output obtained, and input is given from here whose peak value is Vm. So we can calculate the PIV across the reverse bias diode, and we have the output obtained here, V out. Now if we apply the KVL, so we have plus 2 minus Vm, and this is PIV. So PIV obtained here is PIV equals to Vm. So this is the peak inverse voltage factor of half wave rectifier. So now if we calculate the value of PIV for the half wave rectifier, this is equivalent to Vm, that is the peak voltage. So if we exceed this value, then there may be the chances diode can be not sustain up to a longer period of time. Now next is full wave rectifier, and this is of two types. One is center tape rectifier and other is bridge rectifier. I will just brief you about these two topics. We will going to have a detailed discussion in the next lecture. So first of all, we will talk about the center tape rectifier. Center tape rectifier basically tells about center tape rectifier is a full wave rectifier. So in full wave rectifier, we have this input and the obtained output is utilizing the full cycle, both the cycles. So we have the input in full wave rectifier V in, and we have this output. So if we have the peak voltage Vm, we obtain the peak voltage Vm for all the cycles, for positive cycle and negative cycle both. And we have a time period of 0 to 2 pi here. So for the output signal, we obtained the time period is pi only. So by considering these changes, we can also perform the derivation of different parameters here. So first of all, if we talk about the center tape rectifier, or that is the full wave rectifier is a circuit. We have various parameters which is differed. We had studied about the VDC obtained in full wave rectifier will be Vm 2 Vm by pi, that is double of half wave rectifier, Vm by pi. So this is half wave rectifier and this is full wave rectifier. And if we talk about the IDC, it is also 2 Im by pi, and which is obtained for half wave is Im by pi. Third is VRMS is Vm by 2, Vm by root 2 in case of full wave and Vm by 2 in case of half wave. Similarly, IRMS is Im by root 2 in case of full wave, and in case of half wave rectifier it is Im by 2. Efficiency we talk about, efficiency we talk about, eta is around 81.02% in full wave and 40.8% in half wave rectifier. So these are the differences which we can obtain for the half wave and full wave rectifier. So on the basis of these differences, we can say full wave is better for the conversion of the signal from AC to DC. So now next we are going to talk about the center tape rectifier and full wave bridge rectifier. Center tape and full wave bridge rectifier can also be differed in certain parameters. Full wave bridge rectifier, center tape rectifier and bridge rectifier are differed by center tape rectifier is bulky in nature. This is bulky, use of transformer, and it has also peak inverse voltage which is 2 Vm. That means it is not reliable for a longer period of time. But for the full wave bridge rectifier, not bulky in nature and can be easier circuit as compared to center tape, and its PIV is also Vm, so it can be reliable for a longer period of time. But only the difference is it uses, center tape rectifier uses 2 diodes and bridge rectifier uses 4 diodes. So these are the brief description about the full wave rectifiers, that is center tape and bridge rectifier. We had discussed about the difference between these two types of rectifier on the basis of both their characteristics, parameters, and now next we are going to discuss about their derivations in next lecture. So thank you for this, or Jai Hind to all of you.